Today I am going to discuss about the numerical problems in corona in over a transmission line. Go through the problem. A three-phase line has conductor 2 centimeter in diameter spaced equilaterally 1 meter apart. If the dielectric strength of air is 30 kV maximum per centimeter, find the disruptive critical voltage for the line. Take air density factor delta equal to 0.952 and irregularity factor m not equal to 0.9. All of you go through the problem. In the problem, clearly they are mentioned the system is for three-phase system. The system is for three-phase system, has conductor 2 centimeter in diameter. They are given, that is the diameter is 2 centimeter. The diameter is 2 centimeter. But for us required for radius, that is radius is half of the dia. That is radius is half of the dia, r equal to d by 2. That is 2 by 2, we are getting 1 centimeter. 2 by 2, 1 centimeter. Spaced equilaterally 1 meter apart. That is the spacing of the conductor d equal to 1 meter. But here the radius it is given in terms of centimeter, but the spacing is represented in terms of meter. Convert the both either in terms of meter or centimeter. Now the spacing we can convert it in terms of centimeter, that is 1 into 10 square centimeter. That is we are getting the spacing is 100 centimeter. That is d equal to 100 centimeter. If the dielectric strength of air is 30 kV maximum per centimeter, here the dielectric strength is represented for G0. The dielectric strength in the problem they are given G0 equal to 30 kV. That is the value they are given for the maximum 30 kV per centimeter. But here we are substituting the RMS value. That is the RMS value is 30 by root 2. 30 by root 2. That is we are getting 21.21. 21.21 kV per centimeter. 21.21 kV per centimeter. Find the disruptive critical voltage. Here we want to find out the disruptive critical voltage that is represented for Vc. We want to find out descriptive critical voltage that is represented in terms of Vc. Take air density factor. That is in the problem they are given the air density factor, that is delta equal to 0.952. Delta equal to 0.952, and the irregularity factor that is represented for m0. That is m0 equal to 0.9. m0 equal to 0.9. In the problem, they clearly mentioned that is the three-phase system as conductor 2 centimeter in diameter. That is the diameter they are given capital D equal to 2 centimeter. But for us required for the radius, that is r equal to half of the dia. 2 by 2, we are getting 1 centimeter. The space equilaterally 1 meter apart. That is the spacing of the conductor they are given 1 meter. That is one conductor to the another conductor. But the spacing is represented in terms of meter, but the radius is represented in terms of centimeter. For simplification, easiest purpose, we can convert the both parameter in terms of meter or centimeter. In terms of meter or centimeter. Here we are converting. Here we are converting the spacing d equal to centimeter. That is 1 into 10 square centimeter. That is 100 centimeter. And the problem they are given. If the dielectric strength of air is 30 kV, that is G0 equal to 30 kV per centimeter, we are represented in terms of RMS value, that is 30 by root 2, 21.21 kV per centimeter. Here we want to find out disruptive critical voltage, that is represented for Vc. and take air density factor, that is delta equal to 0.952 and irregularity factor m naught. Irregularity factor m naught. Here we want to find out the critical disruptive voltage. Already we know that is Vc equal to m naught g naught delta r log base e d by r. This is the formula. Vc equal, that is critical disruptive voltage, Vc equal to m naught g naught into delta r log d by r. We know the value of the m naught, that is what is the value of m naught? Here they are given the irregularity factor is 0.9 and the g naught, the dielectric strength of air, that is 21.21, need to substitute RMS value, and air density factor, that is delta equal to 0.952 and r, that is the radius of the conductor 100 centimeter, log radius r is 1 centimeter and log d by r, that is the spacing of the conductor is 100 and the radius is 1. The radius is 1. All the data is there. Substitute the formula, we will get the answer. This problem they are given based upon the parameter, we can simplify. Here the disruptive critical voltage represent for the Vc and critical visual voltage is represent for Vv. Now go through it. Here they are given the conductor radius, that is in the problem they are given the diameter, but for us required for the radius, that is 2 centimeter diameter, that is radius half of the 2 by 2 1 centimeter, and conductor the spacing 1 meter apart, but the radius in terms of centimeter they are converted. The spacing is also in terms of centimeter, that is 1 meter is 10 square centimeter, and the dielectric strength of air G naught 30 kV maximum per centimeter, but we are converted in terms of RMS value, that is 30 by root 2. 30 by root 2. We are getting 21.21 kV per centimeter, that is the RMS value. Here we want to find out that is critical disruptive voltage Vc, and the air density factor they are given delta 0.952 and irregularity factor m naught 0.9. Substitute the value, that is the irregularity factor m naught 0.9 and dielectric strength of air G naught 21.2 and air density factor delta 0.952 and the radius of the conductor is 1 centimeter 1 log d by r. The spacing of the conductor is 100 centimeter, the radius is 1 centimeter. In Calc, log base e you can take Ln. In calculator, the log base e you can take Ln. For simplifying, we are getting 83.64 kilovolt per phase. 83.64 kilovolt per phase. But finally, we need to represent in terms of line voltage. This is per phase, that is phase value, RMS value. But finally, we can represent in terms of the line value. We can multiply with respect to root 3. That is root 3 into 83.64. That is we are getting 144.8 kV. 144.8 kV. And go through the next problem. The next problem is a three-phase line has conductor 2.5 centimeter in diameter, spaced equilaterally 3 meter apart. If the dielectric strength of air is 21.21 kV RMS per centimeter, find the disruptive critical voltage for the line. Take air density factor delta equal to 0.953 and irregularity factor m naught equal to 0.92. All of you go through the problem. Here also clearly represented, the system is for three-phase system. The system is for three-phase system. As conductor 2.5 centimeter diameter, 2.5 centimeter diameter, that is D equal to 2.5 centimeter. But for us required for radius, that is the radius half of the dia, R equal to D by 2, that is 2.5 by 2, 2.5 by 2, we are getting 1.25 centimeter, 1.25 centimeter. Spaced equilaterally 3 meter apart, that is the spacing of the conductor is 3 meter, but the radius in terms of centimeter, the spacing of the conductor in terms of meter. So the convert the meter into centimeter, that is 3 into 10 square centimeter, that is the spacing d equal to 300 centimeter, 300 centimeter. If the dielectric strength of air is 21.21 kV RMS per centimeter, directly they are given for the RMS value, that is dielectric strength of air G naught equal to 21.21 kV per centimeter, that is kilovolt per centimeter. The value is for RMS value. The value is RMS value. Find the disruptive critical voltage. Here we want to find out the disruptive critical voltage, that is VC. We want to find out descriptive critical voltage VC. Take air density factor, they are given, that is the air density factor delta equal to 0.953, 0.953, and the irregularity factor m naught equal to 0.92, 0.92. Suppose in the problem they are not given for the irregularity factor, means defaultly you can take, you are assuming under the smooth conductor or polished conductor, the irregularity factor m naught equal to 1, and the air density factor is also assuming for unity. For rough surface and then dirty surface conductor, the irregularity factor is 0.92 to 0.87. Now in this problem, they are given the data, clearly they are mentioned. The system is for 3-phase system and the diameter is 2.5 centimeter, but for us required for the radius, that is half of the dia, that is d by 2, we are getting 1.25 centimeter. And the spaced equilaterally, that is all the sides you should be equal. In 3-phase system, spaced equilaterally, that is all the sides it should be equal. That is it consists of 3 conductor, R phase, Y phase, and then B phase, or else you can take the conductor A, conductor B, and then conductor C. All the sides should be equal. AB equal to BC equal to CA. AB equal to BC equal to CA. That is the spacing of the conductor D1 equal to D2 equal to D3 equal to D. If it is unequal, means it should be changes. This is symmetrical spacing. All the sides should be equal. Now it consists of 3 conductors, that is the 3-phase system. We are assuming this is the conductor A, conductor B, and this is for the conductor C. The equilateral triangle means all the sides should be equal. That is, we are taking D1, D2, D3. Now that is D1 equal to D2 equal to D3 equal to D. That is the spacing of the conductor in the problem they are given 3 meter apart. That is radius already they are given in terms of centimeter, but the spacing of the conductor in terms of meter converted in terms of centimeter. That is 3 into 10 square centimeter. That is 300 centimeter. And the dielectric strength of air they are given G naught 21.21 kV per centimeter, the RMS value. That is directly they are given for the RMS value. This 21.21 kV per centimeter. Find the descriptive critical voltage. Here we want to find out the descriptive critical voltage is VC. Take air density factor, they are given delta 0.953 and irregularity factor m naught 0.92. Here we want to find out descriptive critical voltage. What is the descriptive critical voltage? That is VC equal to m naught G naught into delta R log d by R base C, log d by R base C. That is kilovolt per phase, kilovolt per phase. That is we are getting the RMS value. The finally we can take for the line value, that is multiply with respect to √3. All the data is there. That is the irregularity factor M0 is 0.92 and the air density factor G0 21.21 and air density factor delta 0.953. Radius of the conductor is 1.25 log d by r. The spacing of the conductor is 300 and the radius is 1.25. Just to go through this one, given data, this is the clearly mentioned the three-phase system. The diameter is 2.5 centimeter. In the problem, clearly they are given the diameter is 2.5 centimeter, and the spacing of the conductor is the equilateral triangle. All the sides should be equal. D1 equal to D2 equal to D3 equal to D. This 3 meter, and already the diameter they are given in terms of centimeter. The spacing is also we can convert it in terms of centimeter. That is 3 into 10 square centimeter. We are getting 300 centimeter. And the dielectric strength of air directly they are given for the RMS value, that is 21.21 kV per centimeter. Find the disruptive critical voltage. Here we want to find out VC. Also they are given the air density factor delta 0.953 and irregularity factor M0 0.92. But here they are given for the diameter, but for us required for the radius, that is half of the dia. That is disruptive critical voltage. We know that VC equal to M0 G0 delta R log d by r basic kV per phase. That is VC equal to, what is the irregularity factor? 0.92. Irregularity factor, that is 0.92, and G0, the dielectric strength of air 21.21, air density factor 0.953, and the radius, that is half of the dia 2.5 by 2 1.25 log d by r. The spacing of the conductor is 300 centimeter and the radius is 1.25. Now the simplification we are getting VC equal to 127.39 kV per phase. That is RMS value, phase value. But for us required for the line value, multiply with respect to √3. That is √3 into 127.39. Finally, we are getting the disruptive critical voltage is 220.65 kilovolts. And go to the next problem. A 132 kV overhead line conductor of radius 1 centimeter is built so that corona takes place if the line voltage is 210 kV RMS. If the value of the voltage gradient at which ionization occurs can be taken as 21.21 kilovolt per centimeter, the value is RMS value, determine the spacing between the conductor. In the problem, they are given the line voltage, that is the line voltage VL equal to 132 kV, that is three-phase system, overhead line conductor, radius 1 centimeter. But in the problem directly they are given for the radius, that is R equal to 1 centimeter, so that corona takes place if the line voltage is 210 kV RMS value. That is here they are given for the disruptive critical voltage. That is disruptive critical voltage is represent for VC. They are given 210 kV per centimeter, or directly they are given for the 210 kV. There, that is for the line value 210 kV RMS value. But for us required for the disruptive critical voltage per phase, that is VC per phase. In the problem they are given for the line value, descriptive critical voltage per phase, that is divided by √3. 210 by √3, we are getting 121.24 kV per phase. That is kV per phase. This is the phase value. if the voltage gradient at which ionization occurs can be taken as 21.21 kV per centimeter, that is RMS value. Here they are given for the dielectric strength of air, that is G naught, that is G naught equal to 21.21 kV per centimeter. Determine the spacing between the conductor. Here we want to find out the spacing between the conductor D. The spacing between the conductor D. Already we know that what is the formula for disruptive critical voltage, that is represent for Vc, that is Vc equal to M naught G naught into delta R log d by R base E. Log d by R base E. That is the formula is kV per phase, that is RMS value, kV per phase. But here we know the value of the descriptive critical voltage, that is Vc. Here the formula is kilovolt per phase. The substitute the phase value 121.24. The problem they are given the irregularity factor M naught. They are not given the irregularity factor M naught, and the dielectric strength of air 21.21, and they are not given for the air density factor. The radius is 1 centimeter log d by R. We want to find out the spacing of the conductor D, and the radius is 1 centimeter. Here we want to find out the spacing of the conductor D, but in the problem they are not given for the irregularity factor and the air density. If they are not given, means assuming the conductor is smooth conductor or polished conductor, under the smooth conductor and then the polished conductor, the value of the irregularity factor is unity, and the air density factor is also unity. That is assuming under the smooth conductor delta equal to 1 and M naught equal to 1. Now we can simplify the spacing of the conductor. Just go through it. Now in the problem, they are given 132 kV overlay, that is the line voltage is 132 kV, radius of the conductor is 1 centimeter, and the descriptive critical voltage Vc 210 kV, that is RMS value, but for us required for the kV per phase, that is by root 3, we are getting the descriptive critical voltage is 121.24 kV per phase, and the dielectric strength of air is 21.21 kilovolt per centimeter RMS value. Here we want to find out the spacing of the conductor T. But in the problem they are not given for the irregularity factor and then air density factor, assuming under the smooth conductor or polished conductor, the irregularity factor M naught is unity 1, and standard pressure and then temperature, the dielectric density is air density factor is also 1, that is delta equal to 1. Now already we know that is here 132 kV in the sense is considered for the 3-phase system. Vc equal to M naught G naught delta R log d by R base E, kV for phase. And what is the value of descriptive critical voltage? That is the Vc is kV per phase is 121.24. We are assuming under polished and then smooth conductor, the irregularity factor is 1, and the dielectric strength of air 21.21. We are assuming under polished conductor or smooth conductor, the air density factor is also unity, and the radius of the conductor is 1 centimeter, that is R equal to 1 centimeter log d by R. We want to find out the spacing of the conductor D, and the radius is unity. Now the simplifying, we are getting 121.24, the multiplying this one 21.21 into log d base E. We want to find out the spacing of the conductor. Now that is 121.24 equal to 21.21 to log d base E. By the cross multiplication not happen. Here the right hand side the multiplying, this value goes for the left hand side, that is division, that is 121.24 by 21.21 log d base E. Now the value we are getting 5.6. 716 equal to log d base e. Now here we want to find out for the d. The logarithm, it should be go for the left hand side. It is anti-log, that is e power, that is d equal to anti-log of 5.716. Anti-log in the sense it is represent for the e. The anti-log means it is represent for e. Now d equal to e power 5.716. That is the finally we are getting d equal to 303.68 centimeter. D equal to 303.68 centimeter. This is the spacing of the conductor. Okay. In this class, we are discussed about problems of the corona. Here they are given for the value. You can find out for the descriptive critical voltage, and another method. All the data they are given, but they are not given for the air density factor as well as for the irregularity factor. You want to find out the spacing of the conductor. Suppose if they are not given the data, either dielectric, in the problem they are not given means dielectric strength of air, defaultly you can take 30 kV per centimeter, 30 kV per centimeter. But for us required for the RMS value, that is by root 2, 21.21. In the problem, if they are not given means defaultly you can take the dielectric strength of air is 21.21 kV per centimeter RMS value. And another one, they are not given for the irregularity factor. Defaultly we can assuming under smooth conductor or polyester conductor, the irregularity factor is unity, that is m not equal to 1. And they are not given for the air density factor is also under constant temperature and then constant pressure, delta equal to 1. That is we are assuming air density factor equal to 1.